Assalamualaikum. Welcome everybody to the EVSB Academic Podcast channel. And I'm your host, Professor Emeritus Dr. Ghazali. And today we are very lucky and honored to have with us my esteemed colleague, Professor Dr. T.S. Maryam Jameelah Ghazali. Welcome, Prof.
Thank you very much.
We are honored to have you.
Thank you very much.
And before we go any further, I know that the best person to introduce herself is herself, but allow me to introduce briefly what I know of her. We were colleagues together at the Faculty of Engineering and the Built Environment. And she is, I would say, one of the nation's foremost experts on tribology. She is a tribologist and an expert in surface engineering, actually, I think, surface engineering and tribology. She was one of the founder members of Tribos, which is the My Tribos.
Yep.
I'm sorry, My Tribos, which is the Malaysian Society for Tribology. Correct. Yes. I hope that you will say a bit about that, because that is something which is very, very close to your heart. Absolutely. And she's also the Vice President of the Asia Tribology Council. And who's the President, Prof?
Professor from China.
Professor from China.
Yeah.
But before we start with anything, let us know who Prof. Maryam is and a little bit about her background. So please, over to you, Prof.
Thank you very much, Prof. Husna. It's such a pleasure to be here. Okay, a little bit about myself. I was born in Perak, but raised in Selangor. Okay, so you can tell that I'm a Perakian with 08 IC. I got my early education in science rendah kebahasaan Kajang, Convent Kajang, and then moved to a bit religious school in Mahat Haniyah Kajang. After that, yeah, for my secondary. I'm a Kajangan. I'm a Kajang
educated. Yeah.
Until Form 3, and then I continue my secondary education in MRSM Kuala Terengganu, for 2 years. Then I further my degree in USM until my master's, for 1 year, an additional 1 year in USM. At that time, it was in Trono, Perak, and then
what did your master's was on about?
Okay, I did thought course, but that is the first my first encounter with wear and friction of materials, right? Okay, so that's where it started, and then I continue my PhD in University of Sheffield in the UK. So the rest are history.
You haven't said anything about your family. It's
okay,
all
right.
Yeah.
Excuse me. So, I came from a I would say an academic family. Because both my parents are professors. Even though they're from literatures and humanities background, but most of my siblings are into science stream. Okay,
but I'm sure it has influenced.
Oh, greatly.
Your life in one way or another.
Absolutely.
Being such famous professors as well in the humanities, actually.
Yeah. Okay. Somehow I always look up to them. I mean, they're my like a mentor. Yeah. I mean, once I actually look up. I mean, very much to them, and the way they brought us up. All five of us. We are all 5 girls, siblings. And we can tell that they really love knowledge, because like my father himself, he loves to write. Even though now he's already like 82, he still writes, because he said once you're academia, you'll be forever an academician. That's it.
So I like that, and I always try to say to friends, whenever I hear somebody who's writing at 80 or 84, and I always say, I will emulate that.
Very impressive, isn't it?
Yes.
Actually, your mind will be intact. You won't be forgetful or senile easily because you read a lot.
You keep the mind robust,
correct,
healthy, and mentally alert. Actually,
definitely.
Okay. Most of other people in the podcast tell quite a bit about the experience overseas when they had their PhD. Can you please share with us a little bit of that about that? Because you were in Sheffield.
Yes,
in Sheffield with a few of other colleagues from UKM as well.
Correct. And
you were also educated in USM. Maybe we could start with what were if there are any differences between learning culture, research culture of USM, a Malaysian university, a very famous Malaysian research university, and by the way, and Sheffield.
Of course. Okay, my degree and my master's I did it in the USM in Malaysia. So the culture, it's not just USM but also UKM. Most of the time, if we want to do experiments, okay, especially when we want to handle stuff like microscopic, SEM, electroscopy, right? We have to we have to not appoint. We have to get help from the operator of the machines, okay. But in the UK, you have to do it all by yourself. So in a way, you are actually developing.
Be a baby.
Yeah, you're developing yourself. I mean, the skills, how you actually model and handle the SEM. Okay, that at that time it was quite a high-end machine device. Okay, so that you can actually see the very high resolution of your materials. So in a way, we actually handle everything from scratch. Everything from A to Z. So I think that would be such a valuable learning experience. Yeah.
You haven't told us what your PhD was all about. Yeah.
I did my PhD on wear of wrought aluminum alloys at the time. In the end, I actually modeled
wear of metals.
Yes, definitely. Wear of metals, especially on light alloys like aluminum.
And what will the applications be?
Oh, massive, especially for car industry. Yeah. So in the end of the project, I managed to come up with a wear model, especially for wrought aluminum alloys. Yeah.
Okay. Has it won any prizes yet?
Oh, yes. At that time, during my second year of PhD, I managed to bag like silver. Silver medal for my poster competition in in San Diego, wear conference in San Diego.
Very, very how shall I say, prestigious.
I can say that.
Yes. Where the wear journal is a journal that people doing research in wear will all aspire to publish in.
Oh, definitely.
When I met other researchers from Japan in a conference in Europe, I told him, I have a paper in wear about this, and he quickly said, I publish in wear too.
Okay.
So for you at such a level in your study, to have won something for this particular journal, it's something that should be celebrated, I would say.
Absolutely.
Okay.
And then I should give credit to my former supervisor, Mariyam. He's such a gentle soul. He's very kind and approachable, very knowledgeable person.
MashaAllah. MashaAllah. Actually, both of us are very lucky to have such kind,
yes, definitely.
Supervisors.
Correct.
Yes. Kind supervisors are something that we should be always grateful for,
Yeah.
because they contribute a lot to the
That's
way.
why until now,
how
Prof,
we have.
I always tell my student, you have to create that special bond with your supervisor, because after all, we are all humans, right? So that
Yes.
human interaction actually
It's very
counts.
important.
Yes, definitely.
Okay, now everybody has heard how I have introduced you as a tribologist expert, as a surface engineer, but give us a little bit of introduction on what is tribology.
Okay, tribology is actually is a science of friction, wear, and lubrication, and it's actually it is we can actually relate to our daily routine, such as when we run, we use shoes, right? And it all relates to friction. Even when you swipe your device, your mobile phones, that is also considered as friction. And normally we say we would like to reduce friction, okay, because we want to save energy, because from this one study stated that almost at 25% of world's energy loss are due to wear and friction. So we try to somehow try to improve, okay, how we can actually control this tribology, so that we can somehow save costs, materials, and also energy. So this is actually all the elements actually I would say support very much the SDG thing that we are.
Yes, I also want to go into that, and I'm sure it. What SDG would that be?
Okay. 17. I think something to do with energy. I can't remember. I'm so sorry. I'm so minded today.
All right, but I'm sure it can be much related to the current agenda, zero carbon emission, and all that.
Something like that. Yeah. Somehow we like to conserve our resources, and at the same time we save energy. I mean, less friction, less wear. Definitely we can save energy, materials, and costs.
And a lot of processes now in all over the world, but even in a middle developing nation like Malaysia, to save energy and relate it to an SDG, or they say ESG, is now a main concern. So we can come back later on how it has impacted industry in Malaysia, manufacturing sector, and how your research has contributed to that. But there is something very interesting. A part of your studies, I would say not just studies, expertise will be a biomimetic tribology. Can you enlighten us a little bit on that? Biomimetic tribology. Okay.
Okay, when we talk about biomimetic, it has something to do with nature, right? So we know that nature has been all around us for billions of years. Even before we were born, nature is there already, right? It's all there already. Then what you can actually, from the word biomimetic, means that you are mimic that nature, so that you can be applied to your that can improve our daily application, right? Okay, for instance, if you see like gecko's feet, okay, those are all the typical examples. Gecko's feet, lotus leaf surface, so they all have this functional tribological features, okay, in which we see that geckos, they don't need any suction cup to actually detach and attach them while they move. And then like lotus leaf, they can repel water easily, right? So all those.
But how does, for example, a gecko, what mechanism it is that they use so that they'll be able to cling on top of us without ever, well, they do fall on us sometimes, but most of the time they do not. Okay. So what is the mechanism? Because you say that they don't have suction cups.
Okay.
But there must be some kind of a suction for them to stay there.
Okay, this is where physics lies in. Well, you see, when before men discover all these high-end microscope, SEM, TN, whatnot, they don't have any idea, any clue what's going on, right? Okay, so with all the existence of this high-end tools, we managed to observe under the microscope that for each toe of the geckos, they have like hair-like bristles, and each bristles has this branch, and then each branch has, just imagine you have like millions of branches, okay, and on each hair-like bristles, and then
at the end of which,
at the end of the toe, okay, they have bristles, and if you zoom in under each bristles, hair-like bristles, you have like another branch. So you can imagine that there are billions of contact area, contact points.
So what about the contact points?
Okay, so because of once they actually come into contact with any surface,
with a surface,
so they will create that attractive forces, what we call as a van der Waals forces. So they can actually control when to attach. Okay, they have that adhesive forces and detach whenever they want to lift. That's why it's purely physics, no chemical, no chemistry involved. So this is where we can get inspiration. We can actually apply that in medical, surgical tapes, for example, because if your medical adhesive tapes contains chemical stuff, it might give. The patient might get inflammatory or any trauma,
negative reaction.
Yes, that's correct. Allergic reaction, perhaps.
Allergic reaction.
Yeah, so
whatever it is, adverse reaction.
Definitely. So if you actually use or apply this gecko-inspired adhesive tape, then you can get that a safer effect.
Let's get back to the gecko. I'm very interested in the gecko because I'm sure that visitors have viewers. I'm sorry, not visitors. Viewers like me have watched Spider-Man. Okay, and probably I don't know the inventor of Spider-Man comic. Probably looked at the gecko and thought, okay, how can I turn that into a figure, all right, that clings on to surfaces. We'll talk about that later on, how science fiction can actually use some fundamental concepts in physics and apply it to comic characters. Do you think that they have contributed to a public understanding of wear and friction better?
I think they have done a bit of, I'm sure before they do any movie, any film, they do a bit of study, right? They do research. So it is possible that to have that kind of adhesive tape. So when you actually load it, it will stick nicely, and then you unload it, you will simply peel off easily.
Okay, now I'm going to ask a question that I'm sure some viewers would like to ask. Are there surfaces that geckos cannot stick to? That the geckos would fall off? Not necessarily have van der Waals forces. They repel each other. The bristles and the surface repel each other.
Okay, this is where texture actually, will be very interesting. Why? Because it somehow challenged the fundamental engineering discipline. Why I said that? Because normally we were taught like, okay, if you have smooth surface, normally it will low friction. But with texture, like what geckos have, what like our banana leaves have, with certain texture, they somehow they can manage friction efficiently. They can give the addition effect.
Or it doesn't matter what the surface initially is or are, but the gecko or gecko-like creatures, or assuming they're not gecko-like creatures, whatever instruments, gecko-like instruments or gecko creatures, if they are able to detect the surface, and act accordingly to induce structures that will enable them to stick on to the specific surface. So it's a very specific interaction that the gecko or gecko-like equipment have. Well, is that possible, Prof?
Yes, definitely, it is possible.
Has it been invented, this?
So far, from what I've read, they have applied this gecko-inspired addition medical tapes. But okay, that's another example, a good example. Like snake skills. That's very interesting, because snake skill, as you can see, when they move, they don't have any blisters all over their body, right? Efficiently, I mean, they can move on all types of surface, be it rough or rocky, whatever, but they can do it, even not just horizontal but vertically, right? So what's interesting about snakes' skills is they are asymmetric. The skills are asymmetric, so that asymmetric features creates propulsion. So imagine we can actually get inspiration from this, where we can apply on conveyor belts. Let's say if you have a heavy industry conveyor belt that you need to move like a big chunks of rocks, in an inclined direction.
Yes. Okay.
So it will be very efficient. Moving forward without slipping backwards.
So
those are all inspired.
A lot of your work will involve sitting around and looking at nature and getting inspiration.
Inspired.
To inspire.
Okay. We must remember. I think, it actually mentioned our Holy Quran. Quran, right? I think one of the surah, Ali Imran, if I'm mistaken, it says that it reflects upon
the world,
the creation of heaven and earth. That means you have to reflect, okay? So that because reflection leads to discovery. So in other words, if you understand how things how things work, you get that inspiration.
Okay, I know that you have very, very interesting research based on real life biomimetics. I don't have to mention them one by one, have I?
Okay.
But I want you to share some with us, and perhaps we can start with my favorite, which is the shark skin.
Okay.
Maybe shark skin.
Right.
All right. What kind of research and what applications it has done?
Okay.
And I think swimsuits as well.
Yes, definitely.
Okay.
That's the
And the
application.
other one is, of course, our famous banana leaf. All right. So you have these three to discuss about. All right. Let's start with the shark skin.
Right.
All right. The
As for
viewers
shark-
are, I think, probably thinking, what on earth is happening with the shark skin? Okay.
Okay. The thing about shark skin is very unique. Why? As we already know, sharks, whenever they swim in the ocean, they will swim smoothly, efficiently, right? And very quiet. If you compare it to whales, which are very big, the skin of the whales have so many barnacles, marine growth, right? Unlike shark, they are very clean, super clean. And that's why they can simply
glide
swim,
smoothly.
very smooth. So when we actually shark skin consists of this what we call as riblets that have a very sharp. If you look under the microscope, you will see something like what was the name of the aerospace that thing, just like a spaceship, you know. It's like a
nose.
No. What's the name? It's stealth of. Okay,
The stealth fighter.
Okay, the ship was stealth.
Fighter.
So
Okay.
each riblet somehow shaped like a stealth. So it is optimally structured, and the line is very systematic. So imagine that once they actually swim, and that riblet somehow align with the water flow. So that's why they glide very easy. So this is so with this one, with this unique feature can be inspired, and now Speedo, the famous swimwear, has already adopt this idea, and they somehow mimic, and copy this structure in their high-end swimwear, and they found out that they can actually reduce
The drag.
drag coefficient up to 5%, if I'm mistaken. Yeah.
So there was a little bit, not a little bit, a lot of controversy regarding this swimwear, because in professional competitions, people who put on professional swimmers who uses the speedo swimwear, complete speedo they become like fish.
Yes, definitely.
Obviously,
Yeah.
and human beings, due to their external, how should I say, skin structure, poses drag whenever they travel in fluids in water. And I hear that afterwards, after some swimmers putting them on and performing very well, the speedo swimwear was banned.
Yeah.
But it's very Islamic, the speedo swimwear.
Definitely. And beside that, being, very good in introducing drag, they also can be applied to anti-fouling coatings. Okay, because when we compare with whales, with all these barnacles on the skin, you see that with this kind of features, with the sharp riblets, they somehow repel. Other marine growth cannot simply stick on it easily. So we can actually apply that similar structure onto pipelines, because definitely
deep sea or submerged structures,
Yes.
undersea structures. Okay.
So it will improve the efficiency of it.
Okay, before we go in the other two examples, I want to find out, in your opinion, do you think that this shark skin, surface coating, can be applied on not just undersea or submerged structures, but automobiles, automotives, airplanes and things like that?
Yeah, definitely.
Or have they been using the anti-drag surface coating?
Yes. I think from our previous conference in Sabah, tribology related, there's one professor from IC Imperial College. He actually presented on journal bearings with texture similar. He actually, the texture was inspired by, it's another animal, not sharks, but similar to that. And with these structures, somehow it will enhance the efficiency of the the performance for the journal bearings.
But it's not really some sort of, it has become the norm or mainstay of, let us take two industries that will impact a lot in our everyday life, the automotive industry and the aeroplanes industry. Has it become like the norm to put this kind of anti-drag surface coatings as a standard?
I think they have not yet mass produced, but the research has been going on. I think this is where I have to bring up the challenge. The challenge where you want to mimic exactly
what happens
the structure of that living things onto your adjoining device. Okay, that's the challenge.
Because it's twofold, right?
Yes,
it's
definitely.
Not just the material; it's the structure that's very important.
Because we are now limited to let's say if we take 3D printing, the 3D printing process. So 3D printing, the resolution until now is I think it's very limited, up to, I'm not so sure, probably 15 microns. I can't remember, but it's very limited. And if you opt for injection molding, also it is affordable, but it is very limited to certain geometries. So that's the challenge.
Scale.
And skill, definitely.
Skill is the greatest challenge.
Definitely.
Actually.
So I think
you have
it keep on evolving.
You have to have nano injection molding in order to
but I
produce
think
this kind of
soon in
structure.
future, definitely we can achieve. You can achieve that. Inshallah.
You can, inshallah. How many years you think?
I don't know. It has been like more than 20 years now.
More than 20 years.
At that time, during my early PhD years, I remember there's one friend who's working on this. She's very fascinated with all this mimicry thing. But then at that time, it's like this biomimicry things, but it's like a fringe, you know, when people say, oh, it's cute, but where's the quantitative data? No quantitative data.
Only the,
no engineering discipline.
You know,
So
it's only you say the preserve of loony professors.
so, because it's fun to discover all this nature, but when you want to
do serious study,
materialize it, it will be very difficult,
and to publish it
definitely
is even more difficult.
But now probably it's possible because those years it is qualitative. Now you can quantify it. But it takes time.
Yes. Okay, shall we go into the
other
example?
banana
The
leaves.
banana leaf. I said shark skin, banana leaf. What's the other one? I forgot the other one. What did we say?
Well, we have the famous lotus is similar to our banana leaves.
Yes. But I think we better talk about our banana leaf because it's very near to home. Everybody knows about the banana leaf, and they have used the banana leaf in some application or other. So the banana leaf first. Maybe we can remember the third one.
Yes. All right. Okay. Of course, we have to talk about banana leaf because we have that research together, right?
Yes,
and we managed to secure an award in Japan.
Very prestigious
very prestigious award. Okay, on the banana leaves. So what's unique about banana leaves is they have these features that consist of stomata, air pockets, and also that wax, right? So with all this combination, that's why most of the time they appear clean. They were clean, and then water droplets would easily stick on it. It will roll off easily together with all the contaminants and dirt, right? And what else? And we found that what's unique about banana compared to a lotus, they actually react with heat and load. So somehow when we observe under the microscope, whenever we apply load or certain heat, all these unique features, is stomata and air pocket will actually change their structure, and that will somehow give that adhesive effect and give that we call it as a self-cleaning effect on the banana leaf. It's very fascinating.
And I think our PhD student did successfully, I think, developed a material model of how the banana leaf surface actually achieves its banana leaf effect.
Correct.
And the investigation, maybe a little bit about the application of the banana leaf. And how it bodes well with our traditional application. You should probably mention
right.
well.
Okay. I should give credit to my mother-in-law then. Well, you see, in Malaysia, I actually got this idea from my mother-in-law, so credit to her. Last time she said that during those days they use iron with coal inside, right?
The brass iron.
Yeah, the brass iron, traditional brass iron, the heavy one. So whenever they want to iron clothes, right? Some of the coal might stick on and adhere onto the clothes, right? And with time, there will be dirt on the plate of the iron. So in order to clean, the dirt on the iron, that's the stick onto the iron, they took this banana leaf, a fresh banana leaves. So they simply, when it's hot, they simply glide onto the banana leaves, and several times somehow the dirt adhered onto banana leaves. So that's where we said it's very fascinating. So why do we study this? And then we found out that indeed banana leaf has this self-cleaning effect.
Yes, but we still need to develop the actual surface the material, a physical model to really find out what is happening when you have all these very interesting surface interactions. Okay. I want to mention another plant which is very famous also in the Malay world, But before that, I want to share about the banana leaf. Actually, the banana leaves, the young banana leaves, are used as like a bandage.
Oh, to protect, to heal wounds.
To heal wounds.
Yes. I see. Yeah.
Because that they have chemicals called allantoin.
Allantoin.
And apparently, these allantoin are only there when they are very young. The banana leaves, not when they are old. So it's an evolving thing, and that is why when I think we did the research on the banana leaves, we were very careful to specify the age of the banana leaves.
Yes, correct. Yeah. Because you only select certain age for banana leaves. Correct. Yeah.
Okay. Prof Yam mentioned that she owed a note of gratitude to her mother-in-law. Because from her mother-in-law, like a local wisdom.
Yes.
Kearifan tempatan kan?
Yes.
And there is another kearifan tempatan from the Malay world, which is from a proverb. Kalau keladi leaf ni, pokok daun keladi.
Ibarat mencurah air ke daun keladi.
Bagai mencurahkan.
That is super hydrophobic, definitely.
Yeah. So perhaps can you elaborate on that?
Okay.
And, before, I especially viewers and younger children, I want them to arouse their curiosity, especially when you have these sayings and perumpamaan. There is a lot of scientific principles behind all this perumpamaan.
Definitely.
So let's go to the mencurah air keladi, atas daun keladi. You can't be, actually it's quite negative. Because when you pour water on the daun keladi, it means you are not very bright or you're just stubborn.
Correct. Yeah. It's like ignoring things, like you go in, go out, something like that. Okay.
So, what is actually happening on the surface of the keladi leaf?
As of daun keladi, it's similar to lotus effect. Actually, they have
it's
this
also super hydrophobic.
They have this. Bumps and humps in nanometer scales, that actually because of that humps and bumps, they have like hairs on that. So whenever rain or whatever, there's a water droplets, because of that, the water drop will actually come into contact with that humps and bumps. So because of that will create a surface tension. So that's why the water drop will be like a very nice sphere. That's why it gives that super hydrophobic effect. So meaning that it will stick on that leaf, it will simply like roll off together with all the dirt. That's why you will see most of the time all this keladi and daun try clean, even though they're in a murky pond.
Okay, so is it possible for us to design self-cleaning technical apparel?
Self-cleaning.
Yeah, self-cleaning technical apparel. I mean, if you work in very, how shall I say it, environments that you get a lot of, I would say, muck. Yeah. For example, on oil platforms. In mines, for example, in situations that really you get into a lot of, I would say, dirt. So is it possible? Because dirt, not just dirt like earth or something like that, but to get rid of harmful chemicals, for example. So is it possible to use the principle of the keladi to design self-cleaning, not just self-repelling, all right? Repelling textiles that you use in extreme engineering applications.
I think it is possible. Why? Because like Speedo, they already tried on their swimwear, right? Even though it's more into like reducing drag, but at the same time, just like sharks, they have this like anti-adhesion. By the barnacles, the marine growth. So I think it is possible for to be applied into apparels. But nowadays, I don't know whether you have heard Pilkington's glasses. Have Have you heard about that? It's quite famous.
Yes.
The symbol. I mean, they have this symbol like cross symbols. I think it's made in Britain. They're very famous.
Yes,
most of the
Yes, they are.
skyscrapers, and even in Malaysia, they use this brand, Pilkington glass, tempered glass.
Yes.
So you can see that we don't need to wash or clean the
Self-cleaning.
our glass all the time. It's always appear clean despite
So they have to use it
heavy
in what?
pollution. Whatever.
KLCC or
Ah,
something
yes,
like
yeah.
that. So does KLCC use Pilkington
I'm not so
glass?
sure.
You're sure?
I'm not so sure.
You're not
But
sure
always
because
like
we
appear
see that
clean,
people
right?
cleaning the tall
But they
towers.
do have cleaners, right?
Yeah.
Once in a while, but not all the time.
Not all the time.
Yeah.
So it's theoretically not possible to have 100% 100%
100%.
self-cleaning self-cleaning glass.
Yeah.
But is it possible to make a self-cleaning a soap,
So
soap that you put, or a cream that you put on your skin?
I actually come across one article that actually say, I don't know whether he or she, the researcher, already materialized or not. Nail polish. So it is possible. It has been done. The nail polish somehow the nail polish can actually repel water.
I see.
So-
Which is not very, not very Sharia compliant.
Sharia compliant.
Not very
Okay.
Sharia compliant.
Okay.
All right, we have heard so much about this super duper biomimetic materials that are amazing, and I think the scientific principles, although they are very innovative, all right, but somehow we do understand what is happening at the surface level. But how well has it been for you to say commercialize it or make strides into industry? How has the acceptance in industry been, particularly in our own country?
Yeah. Okay. The acceptance of the public, especially.
Yes. For example, what have you got one product that can be commercialized?
Okay, at the moment, we're working on this. It's still a pre-commercialization stage. Yeah, I have this what we call as a step is as a footwear. Okay, and actually inspired by sand walking, because when we actually walk on sand, somehow we leave this impression.
Print.
Print
Some
impression.
sort
So
of
they
impression.
actually follow the contour of our feet,
Our
right?
foot,
So we try to try to take that into and apply it in our footwear, meaning that we actually encapsulate certain microballs, microballs of material. This is actually we
In your
use
socks?
underneath
Underneath the socks.
yeah. So it
Is it
somehow
a separate feature, or is it incorporated into the textile?
a separate feature. Yeah,
A separate
and then
feature.
so
Okay,
whenever
you have the sock and you have the micro ball.
yes, underneath. So
What
whenever
size are they? Am I asking too many questions?
it's very unique actually. It
What
depends.
size are they?
It can be customized.
I
because
see.
because
Depending
diabetic,
upon the person's
because
physical constitution.
correct. Because you see diabetic people, they
Yes,
come in
yes.
various sizes and shapes, right?
Okay.
Some of them have a bit of deformed arch, like some like flat feet, right? So
So it's for diabetics, really?
correct, because
Okay.
it actually gives that cushioning effect. Because whenever patients with this ulcer underneath, their foot, normally diabetic patient, they have this what we call as a neuropathy. They actually has lost their sense of pain. They sometimes they don't realize they step on nails because they don't feel a thing. That's the problem. So when you actually put that step is and you use the indoors, okay, you can somehow reduce the severity of the ulcer. So in the long run, we can avoid amputation.
Okay, how does the micro balls, in more detail, contribute to the patient feel or whatever gauge, the injury to the foot?
Okay, because you see,
Because I don't get that yet.
okay, because you see with this
microballs,
full of
yeah,
the microballs.
surface.
Okay, somehow it will actually follow the contour of your feet, of your foot, right?
Yeah.
So that's why you said, as I said just now, it actually gives that cushioning effect. So if you have like a bulging ulcer that's starting to form, it will somehow
so it
follow the
follows
contour.
the contour.
Yeah, the contour of the
Yes.
ulcer. Okay.
So is it because of surface, you call it shape memory?
You can say that. Yeah. Unlike commercial products, okay, like we have, like, it's very bulky. I remember you you have one last time, right? And then there's one that can actually
That was not very kind.
it was bulky and expensive, definitely. And there's
It was.
one product they I mean, in order to
And very embarrassing in public because everybody could see it from afar, and you don't want to appear in public. Yeah.
So that's what's this product. They actually put a hole, meaning that it's like a jigsaw puzzle. So when if you have like an ulcer at that particular place, you can simply pull up that puzzle. But it's very, it's not practical. To me, it's not practical. That's why we come up with Step Ease, our product.
So it's called Step Ease.
Step Ease.
Okay, what stage is it in this commercialization process?
Yes. Okay, currently we are applying for the certificate from the MDA, Medical Device Act, and we've already sent our product to the Bioserasi
for testing.
For testing, in order to be certified by the MDA.
Yeah. So you are the inventor. Who else?
Yes. So far, me and one of my friends in UITM, she's a medical doctor, and another medical doctor in UNIZA.
May I know what the socks, the material that you make the socks with?
Okay. Currently, we use a lycra cotton, so it's weakening. It has a weakening effect, and it is very, very breathable.
So it doesn't really the most important structure here is not the socks, but it's the micro beads.
Yeah, that's the structure. We actually
So
patent the microball technology.
If you patent it,
definitely.
the patentable thing there is the micro beads. Or the micro beads.
Yes, we actually patent that microball technology.
Not the lycra itself. Not the what do you call it? Lycra cotton.
Lycra cotton. That's only the fabric.
It's only
to
the
hold
fabric. But is it possible for you to make the shape incorporated, in the socks themselves?
What do you mean? Like shapes in the cell?
Yes, you make the socks into micro beads at the bottom.
Yeah.
You make it into
we did that. Yeah, we did that actually.
beads.
Yeah, we attached that encapsulated microballs and.
Yeah, what are the micro balls made of? It's
proprietary materials.
Yes. Proprietary. But it's not lycra cotton, is it?
No.
What I'm saying is make it lycra cotton as well.
I see. Okay. Thank you very much for the idea.
Yep. So that's another invention.
Okay.
I think that's another invention. All right. So that's you are waiting now for what exactly what IP are you applying for? Is it for utility patent? Is it for trademark?
At the moment, we already have the patent. It's already approved.
It's utility patent. What you have already applied for and been approved. Is that it or what?
I'm not so sure whether it's utility or not. Okay, we actually patent the offloading process. Okay, the microball technology where you can offload the what? The load, especially when we actually walk. Okay, that's the thing that we patented. And now we are trying to protect the name Step Ease, because somehow we come up with that name, and then we would like to protect that Step Ease name with its specific design.
Okay, that's a trademark.
Oh yes, that's a trademark. Yeah.
So, Prof. Maryam, it has been a very exciting conversation we have had.
Indeed.
I think 1 hour passed very quickly, and I'm sure that there are so many other gems in surface engineering,
Yes.
not just biomimicry. Biomimicry is only one part of surface engineering because that's your research, and I'm sure that all our viewers are much intrigued by the things that has been researched by Prof. Maryam. So do please follow us on our academic channel, and if you are interested, which I'm sure that you are, to follow our courses, please do contact us at Entrance Ventures in Sdn Bhd. Until the next time, thank you, Prof. Maryam.
Thank you.
It has been a wonderful time.
Likewise.
So with that, Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.